Assalamu alaikum. Today we are going to do a numerical on the beams, and the first numerical of the beams, that is on the cantilever beam. So this is the numerical which is written on the board. So I'm going to solve this, and I'm going to tell you the step-by-step procedure, how to solve and how to do the calculations and how to draw the shear force and bending moment diagram. So let's first learn the question, then I will show you how to draw the loading diagram, then we'll draw the calculations and SF and BM diagram. So the question is a cantilever beam 4 meter long. So first what we got from the question, that is it's the cantilever beam. So we will draw a loading diagram, and that is a cantilever beam. And a cantilever beam is a one whose one end is fixed and the other end is free. That is a cantilever diagram which I have explained in the last class. And it's 4 meter long, so length of this beam is how much? Yes, it is 4 meter long. It carries 4 point loads. It carries 4 point loads, 2 kilonewton, 3 kilonewton, 3 kilonewton and 2 kilonewton at every 1 meter. At every 1 meter distance commencing from fixed end. So this is the fixed end. So every load is at a 1 meter distance. So that means the one load is here, 1, 2, 3 and 4. See, the first load is 2 kilonewton, 3 kilonewton, 3 kilonewton and 2 kilonewton, and then what it says at every 1 meter distance. So this distance from this to this is 1 meter, so they are 1 meter apart from each other. So my dear students, in case of beams, this is the first thing which you have to do. That means you have to draw a loading diagram. So this is called a loading diagram. After drawing the loading diagram, what the first thing you have to do, you have to give the names. You have to give the notations to these places. So let's say this is point A. This 2 kilonewton is at point A, at B, 3 kilonewton at B, C, D, and this is point E. So we have just given the notations and we have represented where the loads are. This is the second thing which you need to do in case of the beams, whatever beam it is. Now we have the second thing. After that we have to do the calculations. So I will say right here SF diagram calculations. So I will do the calculations. So remember, my dear students, in case of a cantilever beam, you need to start the calculations from the right end. So we have to start the calculations from this end. Remember, in case of cantilever beam, we need to start the calculations from the right end. So I am doing the calculations for SF diagram. So I will, what is SF? SF is shear force, which I told you in the last class, and it is the algebraic sum of all the forces either to right or to the left of the diagram. So I will show you how to do. I will say you that SF at A. SF is the force, shear force. How much force is at point A? It is 2 kilonewton. Okay, 2 kilonewton. I have told you the sign convention in the last class. What this force will do, it will do like this. If this is a beam, this side will go down, the right side will go down, and this will remain at its own place. What is the sign convention which I told you in the last class? Yes, it is a positive. So this is the positive. Now remember one thing. In case of cantilever beam, SF is always positive. in case of a cantilever beam. Fine, my dear students. So you know now SF at point A is 2 kilonewton, that is positive. Now what I say, I will write SF to the right of B. What is to the right of B? To the right of B, is there anything to the right of B? Yes, that is this SF, which is positive 2. What I am saying, if I now take another point, but I am saying SF, shear force to the right of B. To the right of B is only this one. That is, I wrote it back. Now I will say SF, shear force at B. How much is at B? At B it is 3. So SF is the algebraic sum. So we have to, already there was to the right, there was already 2. Now at B there is how much? 3. So I will add that 3. So that means SF at B becomes plus 5 kilonewton. Now we are just adding these forces. Now this is done. Now another stuff. To the right of C, what is SF to the right of C? That means this plus this, that is 5. Should I write it? So I should write it. So SF to the right of C. To the right of C is 3 plus, that's 5. 3 plus 2, that's 5 kilonewton. Now, where? SF at C. So SF at C. Now, one is to the right plus at C. So, to the right was 5. At C is plus 3. As I said, with this sign convention, that means 3. That means plus 8 kilonewton. Now, again, same thing. SF to the right of D. SF to the right of D. What is to the right of D? 3 plus 3 plus 2, that's to the right of D. Yes, it is, that is plus 8. So I can write plus 8 kilonewton. Then at D, to the right of D, now SF at D. So at D is 2 plus 2, its right was 8, that means plus 8 plus 2, that means 10, plus 10 kilonewton. Now SF, okay, you tell me what is SF to the right of, yes, you are right, to the right of E, that is again this whole sum, algebraic sum. So that means plus 10 kilonewton, yes. Now the last thing, SF at E. What is it at E? At E there is nothing, but how much was to the right? It was plus 10, so it will become at E plus 10 kilonewton. So this is the calculation for SF. But the question says we have to draw the SF. But we can only draw the SF when we know its values. So these are its values. Now the second thing needs to be, first we need to do the calculations for BM diagram. So I will write BM calculations for BM diagram. Now we'll do the same calculations, but this time it is for bending moment diagram. Okay, again the bending moment diagram, the calculation starts from the right end. Okay, now tell me, BM stands for bending moment at A, at this A point. In case of bending, there are two parameters. One is the distance and another is the force. At A, there is the force, but where is the distance? No. Remember one thing. No, don't consider this. I'm saying bending moment. Who is going to bend point A? Because we have to take the right side in consideration. So It is at one point. So there is a force, but there is no distance. So therefore, bending moment at the free end of the cantilever is always 0. Remember, this is a golden thing which I am saying to you. Bending moment at the free end of the cantilever is always 0. Then, now we'll go to the point B. BM at B. Now, who is going to bend point B? Yes, this force is going to bend point B. Do you remember the hogging? Yes, I have given you the sign convention. This is called the hogging. You remember sagging and hogging. Hogging is taken as, sign convention is taken as, yes, negative. So it is, now who is going to bend? The point B. It's going to bend point A is going to bend the point B. Then that means the bending moment is, it's a force which is 2 kilonewton and the perpendicular distance up to point A, that is 1. So it is minus 2 kilonewton dash meter. So BM at B is minus. Why the minus is there? Yes, it is because of the hogging. This is going to happen to the beam. Okay, now let's take BM at C. Now who is going to bend point C? This force is going to bend point C, and also this force is going to bend point C. So that means 2, I will take 2 minus, you know the minus sign now, it's because of the hogging, 2 into distance up to point C. How much is distance up to point C? 1 plus 1, that's 2. Minus, now I will take this force, this 3 into its distance up to point C. How much is that? That's 1. How much is that? That's 4 for 7. 4 and 7, that's minus 7 kilonewton dash meter. Okay, that's the bending at C. Now, who is going to bend point D? So I will write BM at, this was BM at C, sorry. This was BM at C and this is BM at D. Now, who is going to bend point D? This force is going to bend D. This one is also going to bend D, and this one, so there are 3 forces, all 3 are negative. Why negative? Because there is going to be happening what? Hogging in the beam, and hogging is taken as negative. That means the bending, so this force minus 2 and its distance, that is 3. Okay, this is this one done. Then 3 into distance up to what? D, that's 2. Minus 3, this force into its distance up to D, that's 1. How much is that? It means this is 6 minus 3. How much is that? All 3 are minus, go 12, that means 15. So it is minus 15 kilonewton dash meter. Now, BM at E. So I will write this one here. I don't have space in the board. So now maximum bending is going to happen at the fixed end. Remember this thing in case of cantilever beam. So maximum bending is going to happen at point E, which is the fixed end of the beam. So now who is going to bend this point E? This force is going to bend, this is going to bend, this is going to bend the point E, and this one. So all these movements are going to bend point E. So that means bending BM, bending movement at point E. So it's going to be bend this one 2 into its distance, perpendicular distance up to point E. That is 1 plus 1 plus 1 plus 1, that's 4. Minus, this is done, then 3 into its distance, that's 3, minus this 3, its distance up to this point, that's 1 plus 1, that's 2, and then this 2 into its distance up to E, that's 1. And how much is that? That is 8 minus 8, 9, 6, 2. And how much becomes that? It is 10 and it is 25 minus 25 kilonewton dash meter. That is the maximum bending. In case of a cantilever beam, the maximum bending occurs at the fixed end. That is the point 1 which you need to remember. And the second thing, the maximum shear force in case of a cantilever beam is also at where it is fixed, that is point E. So it was 10, so maximum shear force and maximum bending. Now after doing these two calculations, what we need to draw the SF and BM diagram. Now I will show you how to draw the SF and BM diagram. Let's learn. So first of all, we have to draw a baseline. So this is a baseline. What is this, my dear students? This is a baseline. Whatever we are going to draw above the baseline is going to be positive, and whatever we are going to draw below the baseline, that is going to be negative. This is the first thing which we need to remember. On this baseline, we are going to draw the SF and BM diagram, and whatever we are going to draw above, that should be positive, and whatever should be we draw below the baseline, that should be negative. This, you know, this all SF values are positive, therefore the SF diagram will be where? Yes, you are right, that will be above the baseline. And all BM values are negative, that's going to be a diagram where it is going to be below the baseline. So you can draw both the diagrams either on the same baseline, or you can also draw a separate baseline for the BM diagram. Remember? Okay, fine. Now let's start drawing. Remember, all vertical loads or point loads in SF diagram should be drawn with a vertical line. Remember what I am saying. All point loads in SF diagram should be drawn with a vertical line. Okay, now at SF at A, how much it is? It is plus 2 kilonewton. So what line we have to draw? A vertical line. So I will draw a vertical line. Without any measurement, I will say this is 2. It is 0 here, and from this point to this point, so the distance is 2 kilonewton. Okay. Nicely try to understand what I am trying to make you to understand. Then is there any load between A and B? Was there any load in between A and B? No, there was no load. When there is no load in between A and B, that means to the right of B, the load was, again it was same. It was 2 kilonewton. When there is no load between the 2 points, then we need to draw a horizontal line. Which line? Horizontal line. That means to the right of the B, we say that load was at A, it was 2, and at this point also it is 2, because it's horizontal. The load remains constant, it didn't change. But at B, SF at B, it has now changed. It was 2, now it is 5. So it has increased how much? 3. So the load between this point to this point has increased 3 kilonewton. Okay, the same things now follows. Between C and B, is there any load between C and B? No. Then what will remain constant? This 5 will remain constant. That is what I write, SF to the right of the C. That is also again 5. So I have to draw a which line? Horizontal line. The load at this point is also 5. Now at C, how much is at C? Now at C it's 8. So it has again increased. How much? It has again increased by 3. So here it is again increased. So it is 3 kilonewton. So it has reached from this point to this point. The load has reached to 8. Okay. Now at between D and C, between D and C, is there any load between D and C? No. Again, then this line will remain constant. This line will remain constant. So at D, how much was SF at D? It was 8 plus 2, that was 10. So it has increased by 2. So 2 kilonewton. Now again, is there any load between E and D? No. Then it will remain constant. At E, it is 10. So we have to close this side. So we will say the maximum is at E. So it is 10 kilonewton. So all the values, you can even write the values, notations here. It is A, B, C, D, and this point is E. You can even write that. Because this whole diagram is positive, so you have to write in the between, it is positive. Then you have to do the hatching. You have to do the hatching. So this was our SF diagram. Now let's draw the BM diagram. As I said, I will take another baseline. So I will take another baseline. Now all the BM values are positive or negative? Negative. That means everything will have to be drawn below the baseline. That's why I will draw all the values below the baseline. So like this. So this is the baseline. Okay. What was the BM at A? 0. So that means this is the first point. At A, this is this A point. It is 0. Now at B, let's take this was, we'll take like this. We'll increase these points. Let's get these points there. Okay. We produced these points. At A, it was 0. Now at B, how much it was? It was 2 kilonewton. So somewhere here, 2 kilonewton. So I will write 2 kilonewton. I don't need to write the minus because it already indicates that it's below the baseline. It's minus. We need not to write there minus. Then at C it was 7. So from this point to this point it is 7. Already 2 here. So 7 somewhere here. 7 kilonewton dash meter. So at D, what was at D? At D it was 15. So somewhere here. At D, this is the D point. See? 15 kilonewton dash meter. And at E, how much it was at E? 25. So I don't have a space here. I need to go down. So I can even go down. I'll just drop this value. So at E, so it is minus 25, so 25 kilonewton dash meter. So we need to connect in case of point load. Remember, all these are point loads. In case of point load, these points needs to be connected with a straight line. You know? So this point and this point has to be connected with a straight line. Again, I will connect this with a straight line. This with a straight line. And then we have to close the diagram. Close this end. Now same things, because this is a diagram, BM diagram is minus, so I will write in the middle, it's minus. Then we have to do the hatching. And it was which diagram? It was BM diagram. So this is what was needed in the question. What we have learned from this question. We have learned in this question that in case of cantilever beam, the maximum shear force and the maximum bending occurs, that means the failure could occur at the fixed end of the beam. That is what we have learned from these calculations and from these two diagrams. I hope you got this question. If you enjoyed this question, I would like to you share this with your friends, and also subscribe if you have not subscribed yet my channel. So thank you very much, and fi amanillah.